Good morning. Today, again with the lecture series of abstract algebra, we are continuing with group and subgroup. Yesterday, we have done some important theorem of group and subgroup. We show the property of subgroups, and I think we have done two or three theorems that AB inverse belongs to H. Yesterday, we proved that A belongs to H and B belongs to H, and H is the subgroup of G. Then AB belongs to H, and this converse is also true. So this is the if condition. If means necessary and sufficient condition. And second is A belongs to H and B inverse to H. So AB inverse belongs to H. These two theorems and the intersection of two subgroups is also a subgroup. So these three very important theorems we completed yesterday. Now, with the continuing of theorem on subgroup, okay, we will go through in this lecture two or three theorems. The objective of this lecture is again the subgroup properties to understand and cycle groups. And after this completion, we have some quiz, very interesting quiz today. So let's start the lecture. Okay. Okay, students. Let's start. Theorem. If A, H and K, if if H and K are two subgroups of group G, then HK is a subgroup group. Here you see the statement that H and K, two subgroups of G, and HK is also a subgroup of G. Let HK subgroup of if HK is equal to K. Let first we take let HK is equal to K. Okay, then we will show that HK is a subgroup of G. Okay. First we assume that HK is equal to KH. Then we will show that HK is a subgroup. Let HK HK inverse. Then this type of term we already did that A and B inverse. A B inverse belongs to H. Similarly, H K H K inverse. Now we can write H K K inverse because given HK is equal to K. So we can write AH is equal to HK. HK HK K inverse. Okay. Sorry. Here we can do inverse for it. This is inverse. Again I do that HK inverse. That means HK K inverse H inverse. That means K inverse H inverse. That means H H inverse because K is a subgroup. K inverse is inverse of K. He belongs to him H inverse. So H this is become K inverse H inverse. So this will become E. That we can say HK is equal to HK inverse is equal to. Okay. Now now again HK inverse HK K inverse K is a subgroup. K is subgroup. So we take K inverse is equal to K. So H K. So here we find K को हम HK is equal to become KH. So we can write HKH. We can write KH H inverse, or this becomes KH. So KH is here we find HK is a subgroup of that's why if we can say HK is a subgroup of. Conversely, now let HK is be a subgroup. That means HK is a subgroup implies HK inverse is equal to HK. Then K inverse H inverse is equal to HK. Now K H inverse HK and HK are subgroup, so H inverse is equal to H and K inverse is equal to, so KH is equal to, therefore we can say, we can conclude that HK is a subgroup implies HK is equal to. This is again, I can explain, given H and K are two subgroup of G, then HK is a subgroup of G if HK is equal to K. So first we take then HK is equal to KH. So HK inverse. If HK is a subgroup, then HAB inverse belongs to its subgroup H. So HK, here we can write K inverse, H inverse, K inverse become E, H inverse become, because H and K subgroup again, HK inverse, HKK inverse. We can write like that, AB inverse is equal to B inverse A. ये हम प्रूफ कर चुके हैं, ऑलरेडी प्रूफ कर चुके हैं इसको, हम ग्रुप में हमने प्रूफ किया था कि ए बी का इनवर्स इज इक्वल टू बी इनवर्स ए इनवर्स होता है, देन एच के इनवर्स बिकम के इनवर्स एच इनवर्स एंड के combined and k inverse become k because k is a subgroup and subgroup का inverse वो subgroup ही होता है. So we have two properties and hk inverse become kh. So hk, we can say hk is a subgroup. Now conversely we take hk is a subgroup, then for a subgroup hk subgroup का inverse भी hk होगा, तो k inverse minus h inverse is equal to k hk because it's the property of subgroup, and k inverse h inverse become hk. This is the, now is one remark, very modern remark. If h and k are subgroup of a commutative group G, then HK is subgroup of G. Now again a theorem, prove that prove that H A plus iota B A B belongs to Q is a subgroup of group C plus. C plus means complex number. Okay. H is a group of A plus iota B and AB belongs to rational number. Then this is a group. This is a subgroup of C plus. Given H is a non-empty subset of C. Let x y belongs to H where x is equal to x1 is equal to a1 plus iota b1, x2 is equal to a2 plus iota. We see H is the type of element A plus iota B. So we take x1 and x2 two element of H. So x1 किस type का होगा A1 plus iota B1 and x2 is also the type of A2 plus iota B2. So we know that H we have a theorem to prove H is a subgroup if A belongs to H, B belongs to H implies A minus B also belongs. We already proved this theorem. So using this, take x minus y implies a1 plus iota b1 minus a2 plus iota b. Now a1 minus a2 plus b1 minus b2. And we know that a1 belongs to q, a2 belongs to q. So a1 minus a2 also belongs to b1 minus b1 belongs to q, b2 belongs to q. Then b1 minus b2 belongs. So this a1 minus a2 plus iota b1 minus b2 also belongs H. We can say x minus y, x belongs to H, y belongs to H implies x minus y belongs. Therefore, H is a subgroup okay. This is a very simple example. Now another example. Prove that H is a subgroup of group group G Vihar. H is equal to A plus B root 2 times implies A belongs to Q, B belongs to Q, and A square plus B square is not. A square plus B square is not equal. Just similar to above example that we have to prove that H is a subgroup of G where H के जो एलिमेंट है वो है A plus B root X. Okay, so again let clearly given that H is equal to A plus. So clearly H is non-empty set. For showing that H is a subgroup, we will prove that X belongs to H, Y belongs to H. Implies X, Y inverse belongs. This is the theorem we already proved. If A belongs to H, B belongs to H, A B inverse belongs to important theorem. Now we take now now we take X is equal to A plus B A1 B1 we can take, and Y is equal to A2 plus A2. Now then X Y A1 plus B1 A2 plus B2. Okay, so we can write like this: A1 plus B1 root 2 with the A2 plus B2. Now we multiply with conjugate. Okay, तो हमें क्या मिलने वाला है यहाँ पे? We will find out A1 A2 minus A1 B2 root 2 plus A2 B1 root 2 minus B1 B2. Here we find out A2 square minus B2 square. So we will find out A1 A2 minus minus 2 B1 B2 minus root 2 A1 B2 minus A2 B upon A2 a2 square minus 2b2. Okay, then we will find this. Now, with comparison, we see that if now if a2 square minus 2b2 square, so a2 is equal to 1 to b2. So a2 is not belongs to, okay. So this must be not equal to 0. So a square minus 2b2 square should not be 0. That means okay, it should not 0. So we can see that a1 a2 minus 2b1 b2 upon a2 square minus 2b2 square belongs to Q is also the product of two rational number is also rational number, and a1 b2 minus a2 b1 a2 square minus 2b2 square belongs. So so it can conclude on conclude that x minus y or x and y square belongs to, that means x. We can write x minus y belongs. So x a plus root 2b ab belongs to q okay. Okay. Yes. So again I can explain it. Prove that X is a subgroup of G Vihar. X is equal to a plus b root 2. A belongs to rational number and b belongs to rational number. Then given us that H is equal to this, that means A and B and belongs to Q. Then it is never be empty. So H is not empty set. Okay. If then we do H is a subgroup, we will prove that X belongs to H or Y belongs to H, then X Y inverse belongs to. Now X belongs to H and Y belongs to H. X we assume that A1 plus because X belongs to H and the element of H are type A1 plus B1 root 2. So X we take A1 plus B1 root 2 and Y we take A2 plus B2 root 2. And X Y inverse. So we take A1 plus B1 root 2 and A2 plus B2 root 2 inverse. Now we done A1 plus B1 root 2 and A2 plus B2 root 2. Now we multiply with conjugate. conjugate से multiply किया and then we find a1 a2 minus b1 b2 minus root 2 a1 b2 minus a2 b1 upon a square a2 square minus 2 b2 square. Now if a2 b minus 2 b2 square is equal to 0, so we get a2 is root 2 b2 and we know that root 2 is not a rational number. So a2 is not rational. This is a controversy because we have already given that a and b are in H and both are rational numbers. So there must not be 0. So a1 a2 minus 2 b1 b2 upon a2 square minus 2 b2 square belongs to Q. It concludes that H is X, Y not belongs to X. That means it is a subgroup. आई थिंक ये बहुत इंपॉर्टेंट क्वेश्चन है और इसको थोड़ा अब अच्छे से करेंगे. नाउ द नेक्स्ट वन. Show that H is a subgroup of G for matrix multiplication. G A B C D A B C D belongs to R. Here A D minus B C H A B 0 D matrix. We have A B C D belongs to R and AD is not equal. Okay. We have to show that H is a subgroup of G. H जो है जो G जो है वो एक ग्रुप है मल्टीप्लिकेशन में. उसके एलिमेंट किस टाइप के ए बी सी डी एक मैट्रिक्स ग्रुप है. दैट्स मीन और उसके सारे एलिमेंट आर से बिलोंग करते हैं. रियल मैट्रिक्स है जी. ओके एंड एच इज ए सब ग्रुप वेयर द एलिमेंट ओनली ए टू वन इज जीरो. Otherwise, all elements same as G. Then we have to show that H is a subgroup of G. Now clearly we see that H is a subset of a non-empty subset of let A B belongs. We have A belongs to A B 0. We take A1 B1. B belongs to A2 B2 0. Then we will show then B will show if A belongs to H, B belongs to implies A B inverse belongs. Now, first we find out. Now, now, first we find out the B inverse. So, B inverse is equal to adjoint B upon determinant of, what is the determinant of B is equal to, here B is equal to A2 B2 0 T2. So this is become A2 T2 A2 B2 और given है A2 A2 is not equal to 0. Then P inverse exists and adjoint B is equal to Mij at the cofactor matrix Mij is equal to D2 0 here minus B2. So transpose of this Mij T equals to D2 minus B2 0. So B inverse is equal to adjoint A. This is become so adjoint A adjoint B upon B determinant. This is become D2 minus B2 0 A2 or this is 1 upon A2. Now AB inverse. We have A is equal to A1 B1 0 D1 A2 D2 D2 minus B2 0 1 upon A2 D2 A1 B1 D2 minus D2 now we will solve this by multiplication minus A2 D2 this row this column A1 D1 A1 D2 minus 0 minus A1 D2 plus B1 A2 0 and this becomes 0 0 and A2 D2 A2. This is the matrix multiplication. Okay, so we get 1 upon A2 D2 1 upon A2 D2 A1 D2 0 B1 A2 minus A1 B2 upon is the multiplication of two real numbers. Is always real. This is always real. This is always. We take this as 1 A2 D2. We can write it A B 0. This is again we can divide by this, and this becomes A upon A2 D2. We simply divide here also. So become we A1 is equal upon A2, or we can write like that because these are the real number and this is the form of elements of H. And if we divide any all the elements, this is the become same. Okay, so this is become. Now we conclude. Now we can see that A A1 B1 0 D1 B belongs to H, B A2 B2 0 D2 belongs to H, implies AB inverse. AB inverse, what is AB inverse? We can take inside A upon A2 D2, B upon A2 D2, 0 D upon A2 D2 belongs. So, so we can say that H is subgroup of G, which is group of okay. So students, again I explain this. This is a very important question. I also write here, very important. Okay, तो इसको अच्छे से प्रिपेयर कीजिएगा इस क्वेश्चन को. Show that H is a subgroup of G for a matrix multiplication, where this is the element of A, B, C, D are, or A, B, C, D all are real numbers. Okay, and H, A, B, 0, D, which subgroup of D, where AD is not equal to 0. This is given. ओके, तो हम इसको प्रूफ करने के लिए क्या करेंगे, वी यूज दैट थ्योरम. इफ एक्स बिलोंग्स टू एच, वाई बिलोंग्स टू एच, एंड एक्स वाई इनवर्स बिलोंग्स टू एच. So we assume that A belongs to H, and A is the matrix A1 B1 0 D1, and B is the matrix A2 B2 0 D2. Now we find out AB inverse. AB inverse, for that we need B inverse. B inverse is equal to adjoint B upon and determinant of B. Then determinant of B we get A2 D2, and adjoint B is equal to the matrix transpose of matrix of cofactor. So cofactor की matrix D2 we get D2 0 minus B2 A2. So transpose it D2 minus B2 0 A2. So B inverse become 1 upon A2 D2 of matrix D2 minus B2 0. Now we multiply this. Now multiply this AB inverse. So this becomes 1 upon A2 D2. In matrix, the multiply with a concept row multiply with column. So here row, first column, first row, first column, second row, first column, Okay, this type, like this type we do the multiplication. I know कि आप लोगों को आता होगा, आई होप अच्छे से। तो हम ये करेंगे और फाइनली वी गेट 1 upon a2 d2 or a b 0 d. This type of element, this type of element exists in H. So we can say H is a subgroup of H. Okay, student. Now I back to the page. Some very fundamental questions are there which you can easily do. This statement is called about subgroup. Okay, I'm just asking that in abstract algebra, real analysis, there are the simply asked question or statement of theorem in multiple choice or other. So we carefully read the statement of a theorem. हर थ्योरम का हमें स्टेटमेंट आना चाहिए तभी, क्योंकि इन ईच क्वेश्चन वी आर नॉट पॉसिबल टू prove the theorem. Okay, so we carefully read the statement of each theorem. Statement is false about subgroup. H is a subset of G. Intersection of, this is a false statement. We have to choose. Intersection of two subgroup is subgroup. AB in H, then AB, A and B two elements in H, then AB not in H, and R plus is a group. See, H first, for first we say H is a subset of G. Definitely H is a subset of G. Then we will show that it is a subgroup. Intersection of two subgroup is always subgroup. Yesterday I proved this theorem, and today I start with this statement that intersection of two subgroups is always subgroup. AB in H, then AB not in H. Yesterday in previous lecture, I proved that if A belongs to H, B belongs to H, then AB is definitely belongs to H. Or in this form, matrix formula, and to example, I use A belongs to H, B belongs to H, and AB inverse belongs to H. So C is the right answer. This is a false. AB it definitely belongs to H. Yeah. The intersection of two subgroups always be subset of G, not subset of G, not have identity element, none of these. Subset of G, this is always subset of G because it is the subgroup of G. Which statement is false? Union of two subgroups. Again, a union, a subgroup. Intersection of subgroup is subgroup. Union of two subgroup, again subgroup, if one subset belongs to other. All are true. The union of two subgroup, again a subgroup. This is only a case. This is a condition based. Because if a subgroup belongs to another subgroup, then the union of a subgroup is again subgroup. So A is false. Which statement is true? Identify of H, identity of H is the same as G. बिल्कुल सही. The inverse element of H is the same in G. This is also right. Identity element is unique in subgroup. बिल्कुल perfect. Definitely right. Because G and H have the same identity element. And all are true. Definitely the 4 on 4th D is absolutely right. So guys, thank you very much to listen me, and I hope you enjoy the lecture. This is a very beneficial for you in future CSR net or at GM and MSc also. So please read it very carefully and patiently. Thank you.